If you're watching this video, you're probably new to 3D printing, or you're one of our fans who's here to help out in those comments below. You guys know what to do. But if you did just get your first 3D printer, be it resin or FDM, there's a lot of lingo that you might not understand. So let's break down a 3D printer and talk about its anatomy. Let's get into it. Hey, welcome back to the channel, and if you're new here, don't forget to get subscribed. And hey, my name's Grant. Welcome to 3D Musketeers. We love 3D printing. I've been doing it for 15 years. We're gonna be talking all about the anatomy of a 3D printer. So if you came to learn, sit back, relax. It's gonna be a fun one. We got some great printers on the table. We got some great knowledge up here. It's time to share it with you guys. If you have any questions about anything on my printers, your printers, or anything like that, you can always email us, youtube@3dmusketeers.com, or toss in those comments below. And if you do want to slide into those DMs on the social medias, you can do so. Links are in that description down below. I personally monitor Twitter, so if you do want to get to me directly, Twitter's normally the fastest way to do it. But let's get into the anatomy of a 3D printer. No, it's not going to be awkward. Much. If you did get your first 3D printer, chances are it looks similar to these ones here. Maybe this, but hopefully one of these. These are filament printers, FDM or FFF as they're sometimes called, for fused deposition modeling or fused filament fabrication. You'll see FFF used a lot because FDM is actually trademarked by Stratasys. That's a whole thing. Don't worry about it. But basically, they take rolls of plastic like this, melt it down, and extrude it through very tiny nozzles over and over again to create components, ones that you'll see all around me here on the set. 3D printing is amazing, and when you boil it down, it is basically a computer-controlled hot glue gun. Take an Etch-a-Sketch, duct tape a hot glue gun to it, and then also move it up and down at the same time. You got yourself a 3D printer, except you're doing all the work and not a fancy brain box like some of these do have. Let's start off with the business end of a 3D printer, the hot end. There are a few key components to know about a hot end. You've got your nozzle, your heat block, your heat break, which is in between the block and the sink, and the heat sink itself. Some hot ends are all metal, some are PTFE lined. We'll get to that in just a bit. The nozzle is where the money is made or lost. The nozzle deals with where the filament comes out. If your temperatures are not set correctly or you're using the wrong material for the nozzle, you're gonna have yourself a bad time. There are lots of options out there in terms of hot ends, but this is one of the most ubiquitous, and E3D V6. But if you do like the upgrade path of things, you can look at doing something like a Revo, and Revos only require one-hand nozzle changes, and it's done when the machine is cold. That's a big benefit if you are just starting out, but it's not required. You can actually see I am unscrewing the nozzle. On the Revo, the nozzle and heat break are one piece, so there you go. Nonetheless, the nozzle is kind of where everything starts. Most 3D printers come with a brass nozzle. This one is hardened steel. Normally hardened steel ones will be black. Stay away from stainless steel unless you are doing things that involve food safety, where you do need something that is not brass-based, because brass does often contain a very small amount of lead, making it not food safe. Nozzles come in a wide variety of sizes, normally as small as 0.25 or even 0.15, if you want to see how dusty your room is and get it to clog up with particles of dust, all the way well above 1.75 millimeters. In fact, we did a video where we made a benchy and other pieces with a 1.8 nozzle. And while it's certainly not the prettiest thing on the planet, this took 11 minutes. This took over an hour. And there's something to be said about that. But if you're just starting out, stick with the stock hot end that comes with your machine, be it all metal or PTFE lined. The way you can tell if you have an all metal hot end is how hot your printer will go. If the manufacturer states that it is limited to 260 degrees centigrade, you have a PTFE lined hot end. And that's okay, but you are limited in the materials that you can print. With a non-all metal hot end, expect to use materials like PLA and PETG, with ABS being on the upper end of what your machine will be capable of doing. If you have an all metal hot end like this E3D V6 or an E3D Revo, you can go as hot as 300 degrees centigrade without any upgrades at all. You can go higher than that, but you will need some special things. Higher temperature allows you to do materials like nylon, polycarbonate, and others that are quite a bit harder to deal with. If you're just starting out, stick with PLA. It's an easy plastic. It doesn't require anything special. It can be run on open air printers in cold environments. You can even have a slight draft if that's necessary. It's a very, very forgiving plastic, and that's why we like it. It's also corn-based, kind of biodegradable. Some companies state it's biodegradable. It is biodegradable only under ideal circumstances, so take that one with a grain of salt. Or kernel of corn? Sure. But the nozzle is what will dictate your materials. Stay away from glow-in-the-darks with a brass nozzle because some of the additives inside of that glow-in-the-dark filament will abrade your brass nozzles. It's actually harder. It's a silica material. Don't worry about it, but just basically stay away from glow-in-the-dark, carbon fiber, and glass fiber. If you want to do those materials, you will need a hardened steel nozzle, but that will mean your temperatures have to be raised. If you're looking to spend a little bit of extra money, you can get a diamond nozzle. Those are expensive, right around the $100 mark, but you can run basically anything through them and you actually end up dropping your temperatures. We talked about this in the past. We'll link to some videos in the description and in the card so you guys can take a look at those if you're interested to learn how the hell they make a nozzle out of diamond, because it's way cooler than you think. But then we get into the heat block. Heat blocks are traditionally aluminum or aluminium for those outside of the United States, and they work just fine well up into the 300 degrees centigrade range. So generally speaking, your heat block, you're not going to need to change it. However, if you happen to over tighten your nozzle or mess something up, the heat block, being aluminum, can easily get stripped out and need to be replaced. Thankfully, they're relatively cheap, and we do recommend you keep spares of all the parts for your hot end in stock, whether it's a spare hot end or just spare components. It really doesn't matter. It's good to have them in stock. This is a copper block. It is very dense, and it is designed to go to temps well above 300 degrees centigrade, printing materials like Ultem, Peak, and PEC. That's a later video. Get subscribed if that's something that you want to see. Between the heat block and the heat sink is a part called the heat break. Now, on this hot end, I can't open it. This hot end's been used. But if you get one that hasn't been, you can go ahead and take off the heat sink, and we're able to see the heat break. As the name might suggest, the heat break breaks the heat between the heat block and the heat sink, and also connects everything together. On something like an E3D Revo, the heat break is integrated into the nozzle itself, so you don't need any extra parts. However, that means the Revo is a more expensive system to utilize, so be careful if you are a first timer. Do note, the heat break is likely going to be the part you end up damaging first if you don't destroy a nozzle by clogging it, so I would absolutely make sure I have spares of those as well. Heat sinks, I don't think I've ever damaged one other than doing things like getting plier marks on it in the past. They work great, and even the cheap ones actually run relatively well. Remember, if you do have a non-all metal hot end, your PTFE liner will go all the way down into the hot zone. If you don't have an all metal hot end, it will stop somewhere before the heat block. That's how you know the difference. Also, of course, the temperature ratings. There are two basic types of 3D printers out there. We have Bowden and direct drive. Bowden 3D printers will normally have a cable, like these two. It can normally be clear, white-ish color, or a blue like this one. What that means is that the extruder, which is the part that pushes the filament through, so that is your drive gears that push the filament into the hot end, is not attached to the machine itself. On this Prusa Mini, the extruder's back here. On the Ender 3V2, hangs on the back side as well. On the Prusa Mark 3S, it's all integrated. You can even see the stepper motor right here. When people say things like steps per millimeter, they're talking about your stepper motor. Stepper motors, as the name suggests, don't move smoothly, they step. And you can feel it when your motors are off and you can turn them slowly by hand. You'll feel it click as it turns. There's a whole thing about it. We'll have an animation on screen as to how they work, but they're really interesting systems that enable accurate reproduction of items. Without stepper motors, most of this is not easily possible. You would need Hall effect sensors and servo drives. It gets complicated, okay? Steppers are affordable and effective. The nice thing about direct drive is there's no extra BS to deal with, and the filament path is very short, meaning things like flexible filaments like TPU or TPE are much easier to print. However, direct drive units are much heavier than Bowden. You can see that this setup right here is a lot smaller than this setup, and I can promise you this is considerably lighter as well. That means, generally speaking, a Bowden printer can move much faster than a direct drive. Now, there are some cases where that is not accurate, but generally speaking, Bowden is also cheaper. You'll find it more on the affordable 3D printers out there, but with machines like the Nozzle SV06, that is a direct drive all-metal hot-end printer, you can get them for relatively cheap. If you're wondering what that machine is and some of the others on my top list of $500 or less 3D printers, we'll card to that series so you guys can take a look. I like Bowdens because you can move them faster, but this tube not being the exact same diameter as your filament, which is good, you want a little bit of wiggle room, means that it has backlash issues, you can have ramming problems. They're more problematic to tune in than something like a direct drive printer. What this means is that direct drive, generally easier to work with, but does most of the time come with an added cost hit. So if you are looking to save some cash, obviously Bowden printers normally come in quite a bit more affordably. To give you an idea, this printer runs about $200. I don't exactly recommend it. This one runs about $500. I would buy this every single day over one of these. This one, the Prusa Mark III's, runs about $800 as a kit and over $1,000 as a fully assembled unit. So a much more expensive printer, but this one is a premium product with premium support. There are more affordable options out there. Further down the line, we look at the actual assembly itself. We've got fans on here, my only fans, if you will. We have 2 fans on most of our machines. Your machine likely has 2 fans on it as well. There is a fan to cool the hot end itself, that is to blow air across the heat sink, and then there is a part cooling fan. On the Prusa Mark III's, the part cooling fan is right here, and over here on the side is your hot end cooling fan. On the ender, you have your part cooling fan, and on the front, you have your hot end cooling fan. Both of those fans are incredibly important for quality printing. If you are having issues with overhangs, chances are you don't have enough cooling. You need to look at going to something a little bit larger. We actually interviewed recently Andy from Hero Me, who designs really awesome cooling systems. They're a bit heavy, but if you want really one of the ultimate cooling systems out there for your machines, it's gonna be pretty hard to beat a Hero Me. We'll card to that video so you guys can take a look. But on Prusas, they're blower fans, 50 by 15 millimeters, for whatever that might be worth to you. They're cheap, they're ubiquitous, and they're very easy to replace. Print failures can cause your part cooling fan, and more specifically, your duct on your machine to get broken. So I'd make sure you keep spares of those as well. Bowden tube is also a great spare item. You don't need any spare extruders or spare stepper motors. Those should not be items that you replace very often, but Bowden tube is always good to have, even if you have a direct drive printer. Bowden tube is great because you can do things like reverse Bowden setups. Video coming soon. Get subscribed. From there, we look at the actual build surface. On Prusas, it is magnetic and flexible, which is really nice because when your parts are done, you just bend the build plate and the part goes flying off somewhere into a low Earth orbit. This one's been used, as you can see, and over time, this material, this PEI or Ultem coating that is on it, does wear out. You can peel the sticker and replace it, or just get a new bed. The second option is easier. Trust me, I've tried doing it the other way. It sucks. Just go buy another bed. They're relatively cheap. And even the Prusa Mini has a magnetic plate as well. Some of the more affordable printers are now also starting to come with magnetic plates. Some of them are textured, some of them are smooth. That's more of a personal preference. Some like it a little bit rough, some a little more vanilla, like it smooth. Machines like the Enders do sometimes come with a glass bed, and you'll see some black polka dots on it generally. That is their material called carborundum, which is a stupid way to say it's silicon carbide, and it's really bad for your nozzles to hit it. If you happen to drag your nozzle across a glass bed, chances are it's time to replace that nozzle. You can run it for a little bit longer, but you might notice extra stringing, layers not laying down perfectly, especially that first layer. Speaking of that first layer, that is the all-important thing about your printer. I often talk about that first layer. If it's not as close to perfect as it can be, you're going to have a bad time. Like we say, if your ruffles have ridges, you are too close. That basically means when your nozzle is too close to the build plate, it is squishing out material from the nozzle, creating a peak. If you feel across that first layer and you can feel peaks, your nozzle is too close, and it is good to adjust your Z offset. That can normally be done from the screen of your printer, or you can do it on the slicer side of things. Speaking of slicers, we're gonna be doing a updated rundown of the kind of most popular open source slicers on the market, so stay tuned for that as well. But generally speaking, if it's a nice smooth piece of glass, or it feels like glass, it's very smooth, that first layer, you're gonna have a great time, as long as all the other settings are right. We're gonna go through those as well at some point in the future. But if you have valleys in between your lines, so if you can see distinct lines and there's a valley in between them and you can feel it, be careful. That means your nozzle is too far away and actually needs to come down a little bit. These are all easy to do. On machines like the Prusas, you can actually do a live Z adjust and change it on the fly. On machines like the Ender here that doesn't have automatic bed leveling, you will need to adjust these wheels. We're gonna have a dedicated video all about bed leveling coming soon, where we utilize Chep's bed leveling tool, and I race my brother to see who can do it faster, Mr. Old School or Mr. New School. It's gonna be a fun one. But when we look at spare parts, and this is my bucket of spare parts, by the way, you're gonna wanna get a few things, mainly heaters and thermistors. There are a couple of types of thermistors out there, so we're gonna start with the heaters to keep things a little bit easy. Most 3D printer heaters will be these cartridge style heaters. They run somewhere between 25 and 50 watts, and a lot of times the color of the wire dictates what it is. You can get generic ones. The official ones from manufacturers like E3D are generally better, but generic ones are good enough if you are on a budget, in my opinion. I always do try to buy legit when possible, but sometimes you can't really afford it. And if you want your 3D printer to run, go ahead and buy the clones for now, but upgrade to legit ones when you can. This little metal cylinder gets, oh my God, hot. And welcome, if you've burned yourself on your Hotend before, you're one of us now. Welcome to the club of 3D printing. This is really what makes everything possible. This gives you the heat. But if you don't regulate that heat, you've got a bit of a house fire. When we talk about temperature regulation, you'll hear people saying things like thermistor. A thermistor is basically like a thermostat, but not. These are either cartridge-based or glass bead-based. Glass beads are more common on the more affordable printers, with the cartridge style being incredibly popular on Hotends like the E3D V6 here. These are what tell the machine what temperature things are. And no, they're just two wires. They're not telling you anything in terms of temperature. What they're actually doing is these change resistance for how much heat they have. So when you put them in between your fingers, your printer can actually detect that temperature change and will show it on the screen generally, which is objectively pretty darn cool. But these can and do get damaged over time. With really thin wires, the chances of a wire breaking is very, very high. So if your printer is saying thermal runaway or DEF or other errors like that, or maybe it's too cold, assuming it's not snowing outside and your printer's not outside, if it thinks it's 0 degrees and it's obviously not 0 degrees ambient, your thermistor is probably dead and needs to be replaced. It is common that the wires on them can break, so be careful of that too. I do prefer cartridge style thermistors. They're a lot harder to break, but the glass bead ones do tend to be cheaper, and they only work with certain hot ends. Same with these. The cartridge style only works with certain hot ends as well. But beyond that, we've got little things like V-wheels and ball bearings and things like that. Generally speaking, a V-wheel on a 3D printer should be tight, but not so tight it doesn't want to move. There's called an eccentric nut, which is a nut that is slightly offset, so when you twist it, it tightens and loosens a little bit. That is what keeps the tension of the wheels on the rails themselves. What this translates into is a way that you can easily tighten the V-wheels as they wear. Yes, your bed and your X and your Y axis and your Z axis are all going to wear eventually and will need maintenance. We're gonna have a maintenance video coming up, so make sure you guys stay tuned for that one. We did one on the Prusa Mini about a year or so ago. We'll card that one so you guys can take a look. Still checks out great for today, but for V-wheel printers, just make sure it's not too loose. A good way to check is to hold the wheel and try to move everything. If the wheel resists moving and doesn't just slide across the surface, that's generally pretty good. I generally tighten them right to when that wheel starts to resist that motion rather than sliding across the rail. That seems to work out fine for me. The big thing with V-wheel printers is to make sure that the channels that they run in are relatively clean. Keep them dust-free when you can. Generally speaking, all 3D printers like to be dust-free. Prusas and some of the other higher-end machines will have a tendency to use steel or chromoly hardened rails with ball bearings that, while louder, hilariously better quality also can mean louder. It's weird. They will last way longer, and if properly lubricated and maintained, they're effectively an item that should never need to be replaced. Whereas V-wheels, I recommend replacing them at least once every couple of years. Now, they're much cheaper, so totally understand that, but it is a good thing to know to service them anyways. You might be looking to do all of these upgrades and change all these things about your printer before you even can start printing. Don't. Please don't. Start slow. You've got this. Get a good quality benchy. I want to see good looking benchies. This one is not a good looking benchy. This is done with a different nozzle. I would like to see good looking models, quality models that we would not include on Print Fix Friday before you start looking into doing some upgrades. That means you have to run your printer slower or use a smaller layer height to get the desired results. That's okay. The nice thing about printers are they don't always need your immediate attention. Now, we don't recommend printing unattended, but you know, if they're in the same room as you while you're doing other things, you'll be able to hear if something is going wrong. Moving on to resin printers, we've got our enclosure for it. This is generally made of acrylic and should block out UV light. We've got our build plate, which generally is removable. Remember, resin is toxic. That is something to note. And something different about resin printers over FDM printers is that they have a vat where the liquid resin can go. They also have a screen that is a wear item and will need to be replaced. But otherwise, they've got ball bearings, they've got stepper motors, they've got touch screens, they've got motherboards, they've got wires. Some of them have thermistors, and there's really not much to them. Resin printers are pretty stout. Just resin is toxic, and I don't want you to hurt yourself. So yeah, that's the basic anatomy of a 3D printer. Let me know what you guys think down in those comments below. And if you like videos like this, make sure to get subscribed. We'd greatly appreciate it. And hey, leave a like if that's your kind of thing. And if you are getting frustrated with your 3D printers, don't forget, we at 3D Musketeers do have professional 3D printing services, as well as 3D scanning, CNC milling, and laser cutting should you need to make your projects awesome. That's all I really have for you guys today. Stay safe out there. Don't forget to call your loved ones. And as always, keep making awesome. Have a good one. Is my breath visible? Is it cold enough in here? No. Okay. Hey, thanks so much for watching this video. A massive thank you goes out to all of our Patreon and YouTube channel member supporters whose names are listed right next to me at the $5 tier and higher. Thank you all for making these videos possible. We appreciate everything that you do. Thank you. Right below me will be our Prusa maintenance video, so you can go take a look at what it takes to keep a Prusa Mini running at tip-top shape. And right next to that will be our series on the slicers. Some of those are outdated videos, so keep an eye out for updated ones coming soon. I'll see you guys down in those comments and in the next one. Take care.